Greetings and welcome to my new calculus channel. My name is John Gabriel. So in a previous video I talked about an easy proof that pi is a constant. Well, there's really not much to say about pi being a constant or square root 2 being a constant or e or the golden ratio so-called phi. Okay, and I'll explain that in a moment. But just to show you how clueless people are. So this person here commented, just use integrals, find the arc length of the circles, and then suddenly a constant starts coming up. Wow, that's amazing. Suddenly a constant starts coming up out of the blue. Scaling the circumferences proportionally to the radii. That's not the reason that the ratio, the measure of the ratio, circle circumference to diameter is constant. And so let's see why. So most mathematics professors and teachers have no clue, first of all, what is a number. And second of all, they have no clue what is a constant. So let's look at the first constant, which is the constant pi. Now, the constant pi is derived from a circle's circumference. So let's suppose that this length here is the circumference of a circle and this is a diameter. Then this line here will also be the circumference, and that will always be the unit. So it doesn't matter how many units you have. If it's 2 units, this line here is still the circumference, and this line is the diameter, and this line here is still the circumference. Okay, so as you can see on the left here, it doesn't matter how you adjust the circumferences or the diameters because they're in proportion. Okay, so look, if I had to join these lines like this, and then I said, okay, let's do this. See, those are all in proportion. And if I had to put a trace on that and do this, see that? That's the reason it's constant. Okay, but I'll come back to that in a little while. So let's get rid of this and this. Okay, we don't need these. So they can also go. Now, how about the constant square root 2? Well, if you've got a square like this is a diagonal, these are the sides. So what does the square root 2 mean? It means that you measure, again, as we saw with pi, we measure this red line with the blue line, okay? We measure this red line with the blue line. Similarly, we measure this red line with this blue line here. So it doesn't matter how you measure it. The measure of this diagonal using either of the sides will always be constant. It'll be the same, okay? Because of what I just explained to you in the previous slide, in the constant pi, right? So now, how about the constant phi? Okay, well, the constant phi has this triangle here, again, which it doesn't really matter how you draw it, as long as the unit is one side and half the unit is the other side. Then this here, hypotenuse, will always be phi, okay, because the blue measures this whole distance here and arrives at the answer 1.61803. So phi is actually equal to the measure of the sum of the hypotenuse and this unit side by the unit, okay? That's what phi is, and it's a constant, and we'll see again why it's a constant. Let's look at the constant e. So the constant e is found from this function here. In fact, it's this distance here is the constant e. And it doesn't matter how you do this, okay? It doesn't matter how you do this. The blue line measuring the red line will always give you the number, the constant e rather, because there is no number e, there is no number phi. None of these are numbers. Well, they actually are numbers, but they're not the numbers that represent the full measure, okay? Because these ratios here, this red line to the blue line, cannot be measured, all right? So it doesn't matter how you do this, right? Whether you have a constant e or a phi. This is what happens when we talk about what measuring ratios mean. So first of all, when you have a ratio, you cannot have a zero consequent, because what does zero measure? Zero doesn't measure anything. But as you saw over here, for example, the constant phi, this top part is measured by the unit. In other words, this red line is measured by this blue line. Okay, so if you had to find the values here and add them up, as I show you here, it's 1.124 and the solid one is 2.515, and the blue is that one. And if you do the measure, it'll come to approximately 1.61083. Okay, so you cannot have a zero consequent. See, both of these red lines cannot be zero. I mean, there's no such thing as a zero line segment. Okay, and that's how numbers are found. So once again, it doesn't matter which number you're using. There are many, many others that have the same measure. And so as long as you keep it in that ratio, then you will have the same measure. Okay, so that's 2/3. This here, this whole red line to this blue line is also 2/3. Okay, so that's what it means to measure a ratio. And of course, you certainly can't have an antecedent that is zero like that. Okay, because then you don't have a measure at all. Nothing measures zero. I mean, how are you going to measure zero with this blue line? You can't measure zero with the blue line. So let's do this. So if you do this, what are you going to measure with the blue line? There's nothing to measure, okay? But now there's something to measure there, right? Do this, nothing to measure. Do any of these here, and you have measurements, okay? So if you say the measurement of 3 by 3, it's 1. The measurement of 6 by 3 is 2, isn't it? You take this here, this part, and you measure the red one. So it's 1, which is, let's get a pen. This here becomes the unit, okay? This here becomes the unit. And then we measure it. 1, we measure the antecedent, which is the red one. 1, 2, see? And you've got a 2. It's as simple as that, all right? So that's what happens when you work with ratios, and why any ratio that's in proportion has the same measure, okay? And of course, as you see, you can't have a 0-0 ratio. That's just nonsense, right? So this is why we know that all these ratios, E, phi, square root 2, or diagonal, and pi have a constant measure, because we can take any other parallel line and those ratios, if measured, will have the same number, the same constant number. And that's what it means to be a constant. So contrary to what you've heard ever before, these are the facts about constants. You don't need limit theory, you don't need calculus. And this guy here or girl, very, very confused, okay? So you certainly don't need calculus to understand a constant. And the ancient Greeks knew very well that these numbers were constants, because they worked with parallelism and proportion, okay? Parallelism and proportion. So they knew any ratio that is in proportion has the same constant measure. Look, let's give you a simple example again. Let's say you have a half, well, that's a half actually, isn't it? Because it's 2 by 4, isn't it? 2 by 4. And if I do that, that's also half. This short red line measured by this blue line is also half. Okay, but I could do it another way too. I could say, let that be 2. Okay, and then I could make that, extend that by itself and extend that by itself. And of course, the new ratio would be 4 to 2. Okay, and again, this here becomes the unit. See, this here becomes the unit. Okay, 4 to 2. All right? So you move that away. There you go. See that? Easy, right? If you're not already a subscriber, become one. I think I've covered this topic pretty thoroughly now. I'm going to move away from it in the next video. If you have any questions, place 1 only in the details section. You can become a member of my channel by simply clicking on any one of my videos like that and hitting the join button. Okay, so all you have to do is hit this little join button, and for a mere $4.99 a month, you have access to everything that I share with the members only group. And in the meantime, nothing's stopping you from becoming a subscriber. Click on subscribe, okay, and become a member of my YouTube channel. So you can do that simply by coming here. Now, where can you do that? Well, you can do it if you just click on my profile and then go to videos and then say more. And then you can click on, let's see, oh dear. So how do you subscribe to the channel? Well, now I'm lost. Anyway, there is a way to do it. And I'm sure it's a lot easier than anything I've shown you here. So actually, it should be as simple as just clicking on one part of the video. Let's just see here quickly. And here. Well, maybe it doesn't appear because I'm the owner. So if you're not an owner, it may show a subscribe button. I think that's what happens. Okay, in any event, there's a way to do it. And you might also want to, the great Archimedes, you might also want to join my Discord group. It's not really mine, but it's on the new calculus. It's this last link here. So you'll get an invitation if you do that. Okay. And I'm not going in there right now, but that takes you to an invitation. And of course, if you haven't already bought my wonderful books, the latest one is a project I'm currently working on. It's called The Importance of Learning the Right Way and What Does Division Mean in Mathematics. It's not just about division. And don't be fooled by the easy introduction. It gets quite involved, and it's not for small boys. It's for big boys, really. So if you're a big boy, you need to buy this book. It's $9.99 on Kindle. Very well then, I'm John Gabriel. This is New Calculus Channel. Till next time.